Hi everybody, welcome to SMR Telugu Education. So next topic is implement queue by using linked list. So here our operations is insert and delete. Insert and delete. So insert is equal to creation of linked list. Create a linked list. So how to create? You have to add at the end of the linked list. Always add at the end of the linked list. Delete. So first queue means first in first out. First in first out. So insertion it always set to end. Deletion is always set to front. Head. Delete at front node. Starting node. So how to create linked list? We already know how to create a linked list. In this linked list, how to insert, how to create a list, that is equal to the insertion in a queue. So deletion at first node, that is equal to deletion in a queue. This is called first in first out. Here I am entering the data. So 10, 20 and then 30 and 40. Now I want to delete, then you have to delete the first node. You have to delete this one. Now we want to add, then you have to add at this location. So if you want delete, you can delete this node. This is called first in first out. First in first out. This is queue. So how to implement this one? So Alt F new F2, file name is q1.c. Here we have to, here data is our wish 10, 20, 30, 40, 50, or you have to take our employee data. So here I am taking the structure name is q. So semicolon is mandatory. Here I am taking int data and then link. Next struct q asterisk next. Here the size of a structure is, int size is 2 bytes, pointer size is, all pointer sizes are equal 2 bytes. Total 4 bytes of memory is allocated. Here by using typedef alias name, instead of writing struct q, typedef struct q, we are writing q. Next I am writing main method. So within the main method, adding is nothing but push operation. I clear the screen, CLR SCR. So push of 10. This is called function calling. Here you need to write function declaration. Function declaration is nothing but return type, function name, then parameter is int. 10 is which type? Integer type. This is called function declaration. Here starting I am taking the head node is global variable. So before main I am taking the head is which type? Q asterisk head. So initial value is, by default value is null, no need to write null. So no need to write null. You have to run this code, we will get an error. Alt F9 will get an error, undefined symbol, null. Here I am including one header file called standard library, hash include standard std.lib.h. Now here we are writing the function definition. So no return type, void, function name, push, type int, some variable name, any name. So this is called function definition. First you have to insert the data. So insert the data is, first you have to check head is equal to null, then allocate the memory of 4 bytes. This is data, this is data, this is next. So base address is 500. So we need to typecast this one. How to allocate memory? By using malloc size of 4 bytes of memory is q. So q size is 4 bytes. So 4 bytes of memory is allocated. We need to type, we are assigning 500 to head. Head is which type? We need to typecast q asterisk and assign this value to head. Now here this is head, this 500 is stored in head, this value is 500. Now this one is pointing to this one. Next here you have to fill the data. We have to fill this data and then this one. How to? This is structured to, dot is structured to member, arrow is pointer to member. This is the pointer. So head arrow data is equal to, so data, next head arrow, next is equal to null, and then return. First, if head is equal to null, if head is equal to null, then allocate memory by using malloc size of q. So we need to typecast this one into q asterisk is assigned to head. So head arrow data is equal to this data. This function calling we are passing the push of 10. This 10 value is copied into this data. We are assigning this data into our head arrow data. Next head arrow next is equal to, next node is not available, then null, then return. Next I want to display this one. So up to this, first there is a function called display. Same, display is equal to linked list display method. So if head is equal to null, then return null value. If head is equal to null, list is empty, otherwise you have to display that values. This is called function calling. So no return type, display no parameters, function name and then no parameters. If head is equal to null, then printf q is empty, then return. So this is called display function calling. We need to declare that function. No return type, void, function name, display, no parameters. This is called function declaration. So alt F9, yes, control F9. Next, display all data. Here you have to take one temporary head of type q struct q asterisk. Take temporary head th. Here the th is equal to head, while th value not equal to null. Then print the data. Printf %d. Here I am giving one arrow, comma th arrow data. Then th is equal to th arrow next. Th arrow next. So this will display all the data. After displaying, here I am writing one print /n statement. This is for every time output is new line. That means I am calling the display second time, output should be in new line. That's why here we are calling printf /n function. Okay, we need to check up to this. Starting value is, execution is always starts from main function. Next, first here I am calling display function. Starting head value is null. Yes, condition. Here control comes here. Head is equal to null. Yes, condition true. Q is empty and then return. Once again we are calling push function. This is function calling. Control comes to this statement. Our 10 value is copied into data. If head is equal to null, yes, condition true, then memory is allocated. And that base address is assigned to head. Head arrow data is equal to starting node address is 10, then null, then return. So once again control goes to this statement. We are calling display function. So once again control comes to this statement. Head is equal to null, condition false, then temporary head th value is equal to head value 500. 500 not equal to null. Yes, condition true. Then 500 data is 10. 10 is printed. Next th value is null. So null not equal to null, condition false, out of the loop. So F7, execution always starts from main function. Display alt F5, Q is empty. So F7 push. So F7, condition false, head is not null, condition false, th arrow data. Condition th value is null, null not equal to null, condition false, out of the loop, alt F5. So 10. Now once again I am push of 20, push of 30. So we are adding push of 40, then push of 50. So adding is nothing but linked list creation. Here this is first node, this is the second node, this is the third node. First node, second node, third node. Here the starting value is, starting address is 500, next address is 600, next address is 700. This is head, head value is 500. Now our head is pointing to this node. This is data, next data, next data, next. Next node is, the next node is 600, next node is 700. So next node is null. Now this one is pointing to this node, this one is pointing to this node. Now this code th value, we are assigning head value to temporary. Here we are assigning head value into temporary head. Then while th arrow next, so not is equal to null, then we are move we have to move th is equal to th arrow next. So after execution of this code, our th value is pointing to 700. This is th, temporary head value is 700. So this one is pointing to this node. Here we are allocate the memory. So allocate the memory. How to allocate memory? By using malloc function. So allocate memory, malloc size of q, two bytes of memory is allocated. We need to typecast this one. So typecast to q asterisk and assign this value to th arrow next. Th arrow next is equal to here this one is allocate the memory and typecast this one to q asterisk and this address. For suppose this address is 800. This 800 is assigned in th arrow next. What is th? 700. Th arrow next is this node, this value. Here this value is replaced with 800. Now this one is pointing to this node. Now th is pointing to this node. We need to move this th value to this node by th is equal to th arrow next. Here th is equal to th arrow next. Next th arrow data is equal to data. Next th arrow next is equal to null. Null. So this is data. This is next. So add this one into our code. So here temporary head which each type q asterisk th. Th is equal to head while th arrow next is not equal to null, then you have to move th is equal to th arrow next. This is equal to creation in linked list. Next th arrow next you have to allocate the memory. size of cube, 4 bytes of memory. You need to typecast this one into q asterisk, assign this one into tharo next. Next you need to move th value into last node, th is equal to tharo next. Next tharo data is equal to our enter data. This one we need to assign this data value into this node, tharo data. Next tharo next is equal to null. This is creation in linked list. This is equal to addition at the end of the linked list. We are adding element always at the end. So Q operation is first in first out. Display function Alt F9, yes, Control F9, Alt F5. So 10, 20, 30, 40, 50. Next we need to delete the operation, that is called pop operation. Now our data is 10, 20, 30, 40, 50. This is 10 is present in first node, next one is 20, next one is 30, next one is 40. Here first in first out. Here we need to delete the first node, head node. How to delete? So this is called deletion in a linked list. How to delete the first node? So how to delete the first node? First here we are writing the pop operation. We are returning the popped element. So return type is integer, printf. So popped element %d comma pop. So return type is integer, function name is pop, no parameters. This is called function definition. So whenever the function return type is integer, the declaration is optional. No need to declare this function here. Here first you have to check if head is equal to null, then printf q is empty, and then return. Otherwise, see first please remember, here we need to delete this node. So we need to delete this node. That means our head value is 500. We need to delete this one. Here we are taking one temporary variable, temporary head. So temporary head, and assign our temporary head value into head value. Head value is 500. Now our temporary head is 500. Now this one is pointing to this node. Next move our head value, this is called head. Next you have to assign our head value is 600. So head is equal to head arrow next. Our head value is 500, head arrow next is 600. Now this head is 600. Now this link is removed. Now our head is pointing to this node. Next here we need to delete this node. We need to delete this node. This address is 500. This 500 is stored in th. Here you have to write free of th. So this statement removes this node. Still th value is 500. Here you have to assign th is equal to null and then return. Now head is 600, this is the 20, next value is 30, 40 and so on up to. Second time we are deleting same. Once again we are deleting 20. Take temporary head. Here no need to write null value. This is a local variable. Whenever control goes to out of the function definition, this memory is automatically deallocate. So here we are taking the temporary head u asterisk th. So you need to assign th is equal to head. Now our head value is 500. Next head value is 600. So that 600 is present in head arrow next. So we need to assign head arrow next value into head. Now our head value is 600. Now our head is pointing to second node. First node is present in th. We have to free that one. So free of th. Next th value is equal to null. So no need to write. So when this is a local variable. Whenever control goes to out of this function definition, this memory is automatically deallocated. So F7 display null. Next 10, to display 10 value. Next 20, next 30, 40, 50. Now our display function is repeated 5 times. Total 5 nodes. 1, 2, 3, 4, 5. Condition false, out of the loop, out of the display. Next our popped element is 10. Head is equal to null. Condition false. Alt F5. Sorry, here we need to return that value. Which value? th arrow data. Here we are declaring 1 into data. So we need to data is equal to th arrow data. You need to return that one. So return data. So we run this code, we will get an error. Sorry, we will get a warning. This function returns no value. This function returns an integer. Alt F9. We will get one warning. Both return and return with a value is used. So warning is not a problem. Once again I am running. Alt F5. So popped element is 10. So once again copy, paste. Once again paste, shift insert. Here the popped element is 10, next popped element is 20, next popped element is 30, next popped element is 40. Next shift insert, next popped element is 50, shift insert. Next is empty. Q is empty. So alt F9, yes, control F9, alt F5. So 10, 20, 30, 40, 50, Q is empty. Here at the end, Q is empty, or return. The return value, some garbage value is replaced here. That's why it is showing. So garbage value at the end, popped element 16. That is the garbage value. So this is called first in, first out. So now I need to push. So here after 30, push 100. So the 30, next remove element is 40, not 100. Alt F9, yes, control F9, alt F5. Now the popped element is 40. At the end, 100 is present. We are adding 100 at the end. So it is popped at the last. So first in, first out. So still you have any doubts? Please refer once again. So here instead of data, if you want, we can give our employee data also. So instead of adding integer, if you want, we can add employee data. Here I am adding struct emp. So every employee has ID, name, salary. Okay. So please refer once again. Thank you for watching.